Hello and namaste. Welcome to in today's lecture video. We solve the example regarding stress and strain topic from the strength of material. So let's get started. Here we have a steel bar. Length is 25 mm, and its tensile stress is equal to 2 into 10 raised to 3 Newton per mm. And it says that determine the total elongation of steel bar. So total elongation of steel bar is we can derive from the strain is equal to change in length divided by original length. So original length is known, but the strain and elongation is unknown. So how we can find it the strain? So according to the Hooke's law, stress is directly proportional to strain up to its elastic limit. So we can say the stress is equal to Young modulus of steel into strain. And but here the Young modulus is not given, but we can say it is the steel bar. So for the plain carbon steel, the Young modulus is ranging from 1.9 into 10 raised to 5 Newton per mm square to 2.15 into 10 raised to 5 Newton per mm. So this ranging capacity is only for the plain carbon steel. In some book it says 2.1, in some book it says 2. So anything. Let's assume here if we take here Young modulus is equal to 2 into 10 raised to 5 Newton per mm square. So now we have a Young modulus, and from this equation we can find strain. So strain is equal to stress sigma t divided by Young modulus. So stress tensile stress is given here 2 into 10 raised to 3, and the Young modulus is 2 into 10 raised to 5. So if we solve this we find the strain is equal to 1 divided by 100. Now we put the strain into this equation, and we can find the change in length or elongation in the given bar. So strain is equal to change in length divided by L. So change in length is equal to strain into length. Strain is equal to 1 divided by 100, and the length is 25 mm. So the change in length is divide 1 by 4, or we can say 0.25 mm. So this way we can solve the example in the strength of material. Now let's solve the another example. Let's assume, say, if it is a steel rod, and its a diameter is equal to say 10 mm, and its strain is equal to 0.7 into 10 raised to minus 3. And let's assume that its Young modulus is value same as the previous example, 10 raised to 2 into 10 raised to 5 Newton per mm. So in here, how we can find the, let's say, determine the tensile load acting on a bar. Here we have to find the load, not the stress. So how we can find stress? So first we have the strain and the Young modulus. So from that we can find the stress directly. So Young modulus into strain. So 2 into 10 raised to 5 into 0.7 into 10 raised to minus 3. When we solve this one, it says 140 Newton per mm square. So from now we have a stress, so we can find the stress is equal to load acting on a point divided by its cross-sectional area. So area can be determined by the diameter we have given here. So area is equal to, we can say, pi by 4 d square. So this is a solid bar, so we can find the diameter by area by pi by 4 d square. So we said load is equal to stress into area. So stress here is 140, area here is a pi by 4, and diameter d is 10 d square. When we solve, we can say the load is equal to 10.9 into 10⁻³ Newton, or we can say 100.9 kilo Newton. So this way we can also solve the example, and these are the most important equation if we read dynamo equation. So what are the important equation here? One is a strain is equal to change in length divided by original length. Another one is a stress one, sigma p by a, and another equation is sigma is equal to Young modulus into strain. Or we can also write down here, this one, rewrite down, strain is equal to sigma divided by Young modulus. So from all these three equations, we can derive the another equation for change in length is change in length is equal to PL divided by AE. If we know the diameter, or if we know the cross-sectional area, if we know the length, and if we know the load acting on the bar, or we can say the stress acting on a bar, and we know the length, then we can directly solve the change in length without going through all these equations. We can just using this equation, we can directly solve it. And that's it for guys, and thank you very much.